Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 10.2, and this is part A. We're going to split this section over 2 days. This section is we're going to cover the axis of symmetry and the vertex. So how do we find the center of that parabola that we can fold it on, and how do we find either the lowest or highest point of the parabola, okay, which also lays on the axis of symmetry. All right, so our warm-up first, we're going to solve each equation. So the first one, we have a linear equation. There's no x squared in here, so we just add 9 to both sides. So we're practicing this skill a little, make sure we don't forget. And then times both sides by 5 over 1, which is the reciprocal of 1/5, and that will make 105. And number 2, this is a quadratic equation. It does have an x squared in it, so our method here is to set this equal to 0. And then factor it so we can split it into two things that multiply to 0, which will allow us to split it into two different problems. So this is 15 and 8. So 3 and 5 are the two things that multiply to 15 and add to 8. And because we have a leading coefficient of 1, we don't have to do our box here. Okay, so this will split into two problems, because one of these has to be 0 or they wouldn't multiply to be 0. So our possible answers are -3 or -5. Okay. Down below, we're supposed to explain how to transform the parent graph y equals x squared to get the graph of each quadratic function below. Okay, so what's been changed here? All right, so this one's still going to open upward. Because a is greater than 0, so that didn't change at all. All right. Then because the c is -2, we're going to shift the vertex, which is the y-intercept in this case, or shift the y-intercept to -2. Okay, and this is because c is equal to -2. And number 3, once we've shifted that y-intercept, which is our vertex, we are going to use this 1/2 to do a vertical compression. So the parabola will be vertically compressed by a factor of 1/2. So it'll get half as tall. All right? So this will make it look wider. And the reason is a is less than 1. Okay? So a's value is less than 1. All right, for number 4, the first thing we would do is shift the parabola up 4 spots. Okay, and that's because c is equal to 4. Okay, that changes the y-intercept to 4. All right. Let's see, -2. So now, because of the negative, a's value is less than 0. This parabola will open downwards. So we shifted our parent graph up 4, and then we flipped it so it opens downwards. Now, stretch here. Because the absolute value of a is equal to 2, which is greater than 1, okay, so absolute value of a is greater than 1, this will make a vertical stretch of a factor of 2, which will make it be twice as tall. And that makes it look skinnier or thinner. Okay? All right, so we talked about this last time, so it should be a nice review for you, and you will see this on your quizzes and tests until we get up to finish up chapter 10 here. Let's flip it over and see the new stuff for today. All right, on the back, we have first directions. Just evaluate the expression. So we've done this before. We have some expression x squared minus 2, and we want to see, hey, what does it equal if x is 3? So we replace x with 3. And remember, whenever you do a replacement, you're supposed to put parentheses around it. Sometimes we leave it off if it doesn't matter, but when it's an exponent above this replacement, it always matters. Okay, so this will become 9 minus 2, which is 7. All right. In our second one, we have 2 times negative 2 squared plus 9. If you leave off those parentheses, you'll get a different answer here. So this is 2 times 4 plus 9. And that's 8 plus 9 for 17. Okay, so don't forget your order of operations here. Don't just write equals 17. All right, properties of the graph of a quadratic function. So here's our list of things of how we graph it. All right, so a quadratic function is y equals ax squared plus bx plus c. And remember, a has to be something other than 0, or we just get a line, okay? All right, so number 1, it opens up if a is greater than 0 and opens down if a is less than 0. We learned this last time. The graph is narrower, thinner, skinnier, okay, if the apparent graph y equals x squared, if the absolute value of a is greater than 1, and it's wider, okay, if the absolute value of a is less than 1. And this is because of the vertical stretch and vertical compressions. Okay, here's a new one. This graph is going to have an axis of symmetry at x equals negative b over 2a. So this is how it decides. Remember, the axis of symmetry is the line that divides the parabola in half. And this is how we decide whether the parabola gets shifted left or right. And it takes both letters b and a to decide how to do that. Okay. The graph has a vertex with an x-coordinate of negative b over 2a. So this point right here is negative b over 2a comma something. We have to find the something, okay? And then lastly, it has a y-intercept of c, and we learned about this last time, okay? So find the axis of symmetry and the vertex of each parabola. Let's take a look at number 3. So the axis of symmetry, and please label this. You can abbreviate it if you want. So axis of symmetry is going to be a line, a vertical line, and its formula is negative b over 2a. All right, so remember in this one, the a is negative 2. That's the part that goes with the x squared, the coefficient for x squared. The b is 12. That's the coefficient for the linear term. And the c is negative 7. That's the constant term. So in this case, we're going to put negative of 12 over 2 times negative 2. So negative 12 divided by negative 4, that makes 3. So our axis of symmetry is x equal to 3. All right, and then we need to find the vertex. Well, vertex is not bad because the vertex, we already know. The first point of the vertex is the axis of symmetry's value. So in this case, remember negative b over 2a comma question mark. So we already know the negative b over 2a, that's 3. So we just need to plug in 3, okay, into our function, and that will tell us the y value coordinate for our vertex. So we have y equals negative 2 times 3 squared plus 12 times 3 minus 7. All right, so this will become negative 2 times 9 plus 12 times 3 minus 7, which is negative 18 plus 36 minus 7. So that's 18 minus 7 for 11. So here is our vertex. So we have an axis of symmetry, that's our first answer, and the vertex, that's our second answer. All right. And number 4, same thing. So axis of symmetry. We don't know what that's going to be. To get that, we say x equals negative b over 2a. That's a formula we're going to need to memorize. And we're going to plug in negative 12, because b's value is 12, over 2 times 3. So negative 12 over 6 is negative 2. So here is our axis of symmetry, x equals negative 2. Okay. Then we need to know the vertex. Vertex is nice because we already have half of it. We just need to get the other half. The x-coordinate of the vertex is the same as the value of the axis of symmetry, so negative 2. And then we plug this back into our formula to find the y-coordinate that goes with it. So 3 times negative 2 squared plus 12 times negative 2 minus 8. This is 3 times 4 plus negative 24 minus 8. Okay, so that's 12 minus 24 minus 8. So that's negative 12 minus 8 is negative 20. Okay, so here's our second answer, our vertex. All right, we'll flip it over and see what's on the other side. All right, on our third page, we're asked to follow the steps to accurately graph each parabola. So number 5, we'll graph y equals 3x squared minus 6x plus 2. Okay, so remember, our a value is 3. That's the quadratics coefficient. Our b value is negative 6. That's the linear terms coefficient. And our c value is 2. That's the constant term. So for step 1, determine whether the parabola opens upward or downward. So a, which is equal to 3, is greater than 0. So this opens up. That means it makes a smiley face parabola. Okay. Find the axis symmetry. Our formula for axis symmetry is x equals negative b over 2a. And in this case, we have negative of negative 6 over 2 times 3. That gives us 6 over 6, which is 1. So our axis symmetry is x equal to 1. And then find the vertex. The vertex is not bad because we already have half of the vertex. To get the other half, we just take 1 and plug it back into our function. So y equals 3 times 1 squared minus 6 times 1 plus 2. And that would be 3 minus 6 for negative 3 plus 2 is negative 1. So 1, negative 1 is our vertex. Remember, this is the bottom point of our parabola because our parabola opens upwards. If our parabola opened downwards, this would be the top point. All right, step 4, use your axis of symmetry in the vertex to determine the place to put the x-axis and the y-axis. And then graph your axis symmetry and plot the vertex. So since our axis symmetry is 1, that's basically the middle of our graph. So I'll just go ahead and draw this in the middle here. So there's our y-axis, okay? And then the vertex is at 1, negative 1. So what we will do is shift our x-axis way down so we can leave a lot of room for our parabola because it opens upwards. And we'll leave the room for it to go up instead of leaving a big blank part at the bottom of our graph. All right? So our axis symmetry is at 1. So I put a dotted line through x equal to 1. Remember, this is dotted because the axis symmetry is not actually part of our graph. It's just the place that divides our graph in half. All right? Next thing, we're going to plot our vertex. Our vertex is at 1, negative 1. So we put a point right there. Okay. So we've done step 4, axis symmetry graph, and we made our x and y axis. Step 5 is to plot 2 other points by picking different values of x. So the first x value we already have is at 1. So number 1 made negative 1. So we'll pick 2, and we'll pick 3. All right. Now the nice thing about 2 is 1 away from the axis symmetry to the right, but 1 away from the axis symmetry to the left is the y-axis. That so means we could use our y-intercept for this spot. So 2 and 0 for x value have the same value. So the 0, which is our y-intercept, is just going to be the c. So the c's value was 2. Okay. So at 0, 2, we'd have a spot on our parabola, and at 2, 2, we'd have a spot on our parabola. All right, so we'll plug in 3 into our equation. So y equals 3 times 3 squared minus 6 times 3 plus 2. So that's 27 minus 18, which is 9, and 9 plus 2 is 11. So 3 will make 11. Okay, that's over here. 3 over and 11 up, so 2, 4, 6, 8, 10, 11. And on the other side, we can mirror it over. This is 2 away from the axis of symmetry, so 2 away from the axis of symmetry is right there. Okay, so this will give us enough points to plot our parabola. And as a matter of fact, if we were to pick another whole number point, we would be off the grid. So our parabola is going to come down like this, curve through our vertex and go back up. And then it's not going to cross over that line there. So mine's a little crooked. This side looks a little better. All right, so down and up. All right, so here's our parabola. y equals 3x squared minus 6x plus 2. Okay, I plotted 2 points on each side of the axis of symmetry plus the vertex in the middle. Now, if you have more points that could fit, obviously you would do as many as you could make fit. All right, but 2 is our minimum. All right, so draw the parabola through the points, which I did, although mine, you could probably do a bit better with your curve on the right side than I did. All right. Okay, let's flip it over and try one more of these. Number 6 here, we want to graph y equals x squared minus 6x plus 11. Our step 1 is going to be to determine whether the parabola opens up or downward. So once again, our a here is 1. That's the number in front of the quadratic term. Our b is negative 6. That's the coefficient with the linear term. And our c is 11. That's the constant term. All right, so since a, which is equal to 1, is greater than 0, it's going to be a smiley face. It's going to open upwards. Okay, so opens up. Find the axis of symmetry. Our formula for axis of symmetry is x equals negative b over 2a. And in this case, remember our b was negative 6, so that's negative 6 over 2 times 1. So that's 6 divided by 2 for 3. So our axis of symmetry is x equal to 3. And we want to find the vertex, so we're going to take the 3 and plug it back in. So y equals 3 squared minus 6 times 3 plus 11. That's 9 minus 18, which is negative 9, plus 11 is 2. Okay, so our vertex is going to be at the axis of symmetry x value, because that's what makes it move over 3 spots to be on the axis of symmetry, and then up 2. So 3, 2 is our vertex. All right, so since 3, 2 is a little ways up above the x-axis, and x equal to 3 is our axis of symmetry, we're going to move our y-axis a little bit to the left, not a lot. So there's our y-axis, and we'll put our x-axis really far down, because the whole parabola is going to be above the x-axis. All right, so x equal to 3 is our axis of symmetry, so we'll put a dotted line through x equals 3. So it's our vertical line. Remember, it's dotted because it's not part of the parabola. It just shows where the parabola divides evenly in half, the symmetry of the parabola. All right, now we're going to plot 3, 2. So that's 3 over. That's 3 takes us to the axis of symmetry, and then 2 up. That's going to be the bottom of our parabola because that's the lowest point. All right, so now we're on to number 5. Plot 2 other points. So we've already used 3. So let's back up and we'll use 2. 1 and 0 and see what happens. And I'm going to pick 0 because it's really easy. I know the 0 already. That's 11. That's the C value. Okay, remember that's where our y-intercept is. All right, so if I plug 2 in, I'm going to go ahead and write this out. So that would be 2 squared minus 6 times 2 plus 11. So 4 minus 12 plus 11 is going to be equal to, let's see, 4 minus 12 is negative 8. Negative 8 plus 11 is 3. So 2, 3. All right, so that's 2 over, 3 up. 2 over, 3 up. And then we try 1. So this is going to be 1 squared minus 6 times 1 plus 11. So that's 1 minus 6, which is negative 5, and negative 5 plus 11 is negative 5 and 11 is 6. Okay, so that's 1 over 6 up. 1 over 1, 2, 3, 4, 5, 6 up. Okay, and we can mirror that to the other side as well. And then we had the 0, 11, so 1 over and 11 up, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we can mirror that over to the other side. And this gives us enough points to plot our parabola. Okay. And we write y equals x squared minus 6x plus 11. All right, now if we stop and think about this for a second and look at our stretches here. So the a value was 1, so that's just like the parent graph. And notice we're still just like our parent graph. So from the vertex, we go right 1, up 1. From the vertex, we go right 2 and up 4. So this, all it did was shift the graph over 3 spots to the left and 2 spots up. All right. Notice our C value is 11, so that's our new y-intercept. Okay. So the C value calls that 11 there. And that concludes our notes for the day. Okay, so we'll practice this in class next time, and then the time after we'll finish up the section, which is finding out the maximum and minimum value. It's not too hard, but it gives us some more problems to practice with. All right, I'll see you in class.